Hi, in this video we'll be talking about the different types of intermolecular forces. Intermolecular forces. And the list will be ranged from weakest to strongest. So strongest intermolecular forces first will be our network covalent solid. And examples of those are silicon and diamond. Next we have ionic and metallic bonds. And these are this can be metal and non-metal, or metal only. Metallic is metal only, and ionic is metal and non-metal. Oops. Alright, next we have, let me number this so that 1, 2, 3. The font's a little bit smaller. 3, we have hydrogen bonds. Our third strongest is hydrogen bonds. And this is anything that is hydrogen bonded to a nitrogen, or hydrogen bonded to an oxygen, or hydrogen bonded to a fluoride. And now, if it's anything that is not one of these three, then it is not considered hydrogen bond. So just because there's hydrogen in it does not mean it has hydrogen bonds. It has to be bonded to nitrogen, oxygen, or fluorine. Next we have dipole dipole. And that only happens in any polar molecule. So any polar molecule will have dipole dipole bonds. Dipole dipole intermolecular forces. And now finally we have London dispersion. Forces, also known as the LDF. And these are all elements have some LDF. London dispersion forces exist in every single atom and element. Now they're mainly nonpolar and usually increase as molar mass increase, because more molar mass tend to have more electrons. And then LDF increase as the electrons increase, because electron distribution is more easily disturbed. Outer electrons are held less tightly by the nucleus and therefore more polarizable. Polarizable means higher LDF, right? So higher the LDF, the higher the boiling point, the melting point, and the harder it is to break the bond. Now, an element can have multiple LDFs. It can have multiple LDF, intermolecular forces. So let's take a look at two examples over here. We have first we have CH4, oxygen. All right, CH4O. Now let's see what kind of intermolecular forces this thing has. So first, let's draw the Lewis structure, right? We have carbon and oxygen connected to 4 separate hydrogens. And to make it octet rule, all of these will have 8. And let's the valence electrons first. We should have done that first, but carbon has 4 plus 4 plus 6, which is 14. And over here, let's see if we have 14. And we indeed have 14. So that means this is how the Lewis structure will look like. And now let's see. All elements have LDF. So this definitely has LDF bond. LDF intermolecular forces, LDF. Second, let's see, does it have dipole dipole? Now, is this a polar molecule? It is a polar molecule from these dipoles over here. So this one will have dipole intermolecular forces as well. And now, let's see if it has hydrogen bonds or not. Hydrogen bonds, it has to be connected to HN, HO, or HF. Do we see an HN, HO, or HF over here? We do. We see this hydrogen is connected to O. So this one has hydrogen bonds as well. And now let's see if it is ionic or metallic bonds. Does it have ionic bonds? It does not. This is not ions. This is all nonmetals. Does it contain silicon and diamond? Does it contain silicon and carbon, which make a diamond? It does not. So these are the only 3 IMFs it will have. Now next, we have K3PO4. So K3PO4 will be, alright, so first I draw PO4, right? POOO. K plus, the 3 minus, K plus, K plus. So this is how it looks like, right? And let's see. All elements have LDF. Is this ionic? It is definitely ionic. So this says dipole dipole. And does it contain hydrogen bonds? We don't even see hydrogen anywhere, so there's no way it contains hydrogen bonds. Now let's look at ionic bonds. Does it contain ionic bonds? It does, because once the cation, once the anion, they're bonding together. So this one has ionic bonds. And now it does not contain silicon or carbon, so that's it. Now if we compare these two, both of these have 3 different intermolecular forces, but ionic bond is stronger than hydrogen bonds. So the strongest bond in K3PO4 is stronger than the strongest bond in CH4O. That means this one, K3PO4, will have a higher melting point and will have a higher melting point, and it'll be harder to break the elements apart. Harder to break the bond. And now here's another thing that you need to know of, and these two have the same exact LDF, same exact properties. No, they do not have the same LDF. They have the same properties, the same type of bonds, because they're the same element. They're isomers. They have the same elements, but one of them will have a higher boiling point, and that will be this one. Higher boiling point means its bonds are harder to break. When you see a longer bond like this, that means the LDF will be lower and the bond will be easier to break. With a bond that's easier to break, it means it has a lower melting point and lower boiling point. That's why the second one will have a higher boiling point and higher melting point, because a longer branch will decrease boiling point, and the first one has a long branch, whereas the second one doesn't. So that's something that you need to know of, and that's it for the different types of intermolecular forces, and thank you for watching.